Okay, so we want to solve this question. So the question reads, one end of a string 0.8 meters long is fixed to a point O, and the other end is fastened to a small object of weight 12 Newton. The object is pulled aside by a horizontal force until it is 0.5 meters from the vertical through O. Find the magnitude of the tensions in the string and the horizontal force. So to solve this question, we need to understand the question before we can even attack the question or try to solve this question. So we said that a string which is 0.8 meters long. So we are assuming that the string is 0.8 meters long, and it fixed to a point O. So let's say this is a point where the string is, let's say, fixed to. And they say that the length of the string is 0.8 meters, like this. The other end is fastened to a small object of weight 12 Newton. So this part being fastened to an object of weight 12 Newton, something like this. So actually this is how the diagram could be drawn. So we all know that weight always acts vertically downwards. So the weight will act this way, vertically downwards. So the next point says that the object is pulled aside by a horizontal force until it is 0.5 meters. So a force was applied here, a horizontal force was applied to this place and pull object until it is 0.5 meters. Until it's 0.5 meters from the vertical. From the vertical, and this is the vertical. This is the vertical. Until it's 0.5 meters from the vertical. Okay. Through O. So through O. So the pulling occurred from this particular end. So actually, if you are to represent this diagram very well, you can see that this was where the string was touched, and then we can trace to this point and say that this was the place where the object was hanged. But now the force was applied and moved the object from its original position to a new position. So we can now say that the objects are being moved, the string and the object being moved to another place. So now it's not at this place again, but it's moved. But the question says that the force moved the object until it is 0.5 meters from the vertical. So from this place to where the object is now is 0.5 meters. But we know that the string, the length of the string is also 0.8 meters. Okay, and then the object which has been fastened is 12 Newton, and as a weight always acts vertically downwards, so I have 12 Newton here. Okay, and they say that a horizontal force pulled the object aside. So a horizontal force pulled the object. So let's say this is the horizontal force which was applied, pull the object from its original position, and that horizontal force will be represented by F. So with this diagram, we can say that this angle can be calculated, because now the force has made a right angle triangle here. So we can now calculate for the angle theta. And using the trig ratio, we can use tan theta here, and the tan theta means that opposite over adjacent. Tan theta can say twa. And then tan theta, it can't work because we don't have our opposite here. So we can use only cos theta. Alright? Cos theta. And cos theta is okay, adjacent over hypotenuse. And we have our adjacent to be here. The adjacent is just a line on which the angle is lying. So the line on which the angle is lying. So that's the adjacent. So you can say cos theta is equal to our adjacent, which is 0.5 over our hypotenuse now, which is 0.8. Here we want to find theta. That's the angle. So we say that theta is equal to the cos inverse of 0.5 on 0.8. When you point cos inverse of 0.5 or 0.8, you get the angle. And the angle theta is 51.36 degrees. So now we know the angle of theta now. But we also need to calculate, that's one thing that I left it out here. We need to replace here by T. And T is just the tension in a string. Okay. So now that we have theta, we can also find this angle. You can say this is, let's say this is O. And let's say this is, let's represent it by B. So we can have OBF. So that when we are talking about the angles, we can easily identify the angles. So we can now find OBF simply from this diagram. So let's say we find the angle OBF. And angle OBF, you know that this, from this point to where the F is we can call it angle on a straight line. And angle on a straight line sum up to 180. So to get the angle OBF, we can just subtract theta from 180. And then theta is 51.36 degrees. So our angle OBF is now equal to 128.68 Newton. This way. So now we have angle OBF. Let's also find angle OB. Let me also represent this place by weights so that we can simply identify them here. Let's also find angle OBW. And then angle OBW, talk about the angle here. Angle at this place. So our angle OBW is equal to this angle plus this angle. And we know this angle to be 51.36 and this angle to be 90. So 90 plus 51.36, which will give us 141.36 degrees. So now we have our angle OBW equal to 141.36. Let's now calculate the angle WBF. Angle WBF. Angle WBF. We can actually see that it's 90 degrees. So angle WBF is equal to 90 degrees. So let's try and see. The question said that we should find the tensions in the string and the horizontal force. So meaning we need T and then F. And for us to get T and F, it means that we should be able to use the theory called the Leibniz theory. And the Leibniz theory, we can use the Leibniz theory by always using the force and the angle that force is facing. So if you are using T, we use the whole of this angle. When you are using F, we use the whole of this angle from this force to this force. When using W, we use the whole of this angle in order to get our forces. So let's try this one and see. So T over sine 180 minus the angle here, which is 90. Is equal to, when we use F, we talk about the angle that is also facing. So, and that angle is sine 180 minus 100, because this angle is 51 plus 90, and then it's 141.336, like this. Is equal to the last one, that's W, weight, and W over sine 180 minus the angle that W is also facing, and that angle is 128.68. 128.68. Alright. So here, let's try and then simplify these expressions. You have T over sine 90. Because 180 minus 90, you get sine 90. And then F over 180 minus 141 will give us 38.68. So still there's a sign here. Should be equal to our W all over sine 180 minus 128.6, you get 51.32. So at this point we know the value for weight, so we can say that T over sine 90 is equal to F over sine 38.68 should be equal to, our weight is known as 12 Newton over sine 51.32. We know that sine 90 is 1, so we can say T over 1 is equal to F over sine 38.68 equal to 12 over the sine 51.32. So at this place, very simple. If you want to find T, we use T over 1 and then we equate it to 12 over sine 51.32, and then we can make T the subject and then we get T. To find our T, we simply say that T on 1 is equal to 12 over sine 51.32. So what shall we see? So we try to cross multiply. This 1 times 12 will give us 12 is equal to T multiplied by aggregate T sine 51.32. We want to find T, so we divide here by sine 51.32 degrees, and then divide the whole of this place also by sine 51.32. So you can see there's a cancellation here, you left it, you would see there. And then 12 over sine 51.32 will give us 15.37 Newton is equal to T. So therefore we can say that our T is now equal to 15.37 Newton. Okay. So for us to find F, we can use any of. We can either use the first one, T over sine 90. Now we have T, and then substitute T, and so we get F. Or we use the F and then with the weight, and so we get our F. So you can say that let's use F over sine 38.68 is equal to, our weight is 12 over sine 51.32, like this. So with these two, we cross multiply them. So multiply F by sine 51.32, you have F sine 51.32. It's now equal to multiply 12 by sine 38 points. So 12 sine 38.68. We want to find F, so divide this one by sine 51.32, and this one by sine 51.32. Sine 51.32, we deal away with the top one. To have our F now equal to 12 sine, when you press 12 sine 38.68 all over sine 51.32. The answer will be 9.61 Newton. Thank you.